Today on How It's Made. Firefighter boots. What's hot in footwear? Garden tools. You'll get the facts in spades. Automated machines. Our annual tribute to those moving marvels. And gypsum board. We're giving this story wall-to-wall coverage. Firefighters need boots they can pull on lightning fast to get to the blaze as quickly as possible. Those boots have to be fire resistant, of course, and waterproof. They have to provide good grip for climbing ladders and be sturdy enough not to puncture when stepping through sharp debris. Firefighter boots start out as a chunky block of rubber. The first step is to put the block through a mill. It passes through the rollers over and over again until it gradually flattens and thins out. Workers then add chemicals, anywhere from 15 to 35 different types, depending on the model of boot they're making. The rubber formulation is what makes the boot fire resistant. Once the rubber is smooth and malleable, about the consistency of modeling dough, they form it into sheets from which they'll cut the various pieces that make up the boot. They feed this sheet through rollers that imprint vertical lines on the rubber. They'll cut the sheet along these lines to make the strips that run down the back of the boot. From another sheet of rubber, using a handheld die, they cut one layer of the multi-layered sole. They run an extra thick sheet of rubber through rollers that imprint a tread pattern. Then workers cut out the bottom soles. They mark the boot size on the bottom. Using yellow rubber, they cut out the boot's toe cap covers. The boot's leg has a stiff lining to prevent it from wobbling. Workers cut it from a rubber-backed cotton fabric following a pattern. Once all the pieces are cut, workers can assemble the boot on a form. They start with the lining, wrapping it around the front and gluing it closed at the back. Then they glue on the insole. For this model, it's made of rubber-backed felt. They secure the lining seam and seal it with one of those rubber strips we saw earlier. Now, the vamp, a piece of felt reinforced with a thin layer of rubber. This gives the boot strength. Next, the toe cap sponge, made of rubber compounds. When they cure the boot, the sponge will inflate and hold this steel toe cap in place. To protect the firefighter's feet when walking through sharp debris, a steel arch and a steel sole. Next, an adhesive-backed toe cap cover. Then a felt sole to protect the firefighter's foot against heat. It has a steel arch for stability when the firefighter climbs the ladder. After applying a rubber heel reinforcement, they cover the lower part of the boot with yellow foam for insulation. They secure it using a strip of rubber. Now they finish the bottom of the boot in black rubber. They reinforce the back and sides in yellow rubber. And finish them off in black rubber. Next comes the yellow toe cap. Then a rubber pad to protect the front of the boot when it rubs against the rungs of the fire ladder. Now the bottom sole. They use a press to seal it in place. Rubber bonds to rubber under pressure. They apply a rubber trim around the bottom, using a small roller to press it in place. Workers then press all the seams to ensure they're well adhered. Then it's into a vacuum machine for about 4 seconds to create an airtight bond. Finally, the boots go into a giant oven that heats them to 140 degrees Celsius. An hour and 45 minutes later, the rubber is cured and hardened, and all the pieces have fused together. These boots are ready to take the heat. Anyone with a green thumb knows that it takes both skill and patience to make a garden flourish. It also helps to have the proper tools on hand. An avid gardener's arsenal can contain everything from shears, trimmers, and pruners to rakes, hoes, and spades. The handles of these garden tools are made of white ash, a sturdy wood that can withstand the force of shoveling, digging, or raking. These dried ash dowels measure 1/2 meter to 2 meters long, depending on the tool being made. They first enter what's called the chucking line, where specially designed automated machines shape them into handles. The first operation rounds the dowels to the required diameter, 4 centimeters or so, depending on the tool. The next operation cuts the dowels to the required length and profiles their ends. Two chucking heads, one on each side, carve the ends simultaneously. One shapes the bottom of the handle to fit the tool's blade. Certain blades go over the wooden handle while others go into it. For those inserted blades, another chucking head hollows out the handle. Meanwhile, the chucking head on the other side rounds off the top of the handle. The finished handles spin against a sanding belt as they exit the chucking line. This smooths the surface of the wood, preparing the handles for a coat of protective varnish. High-end shovels and spades have what's called a steel D-grip, a steel handle grip with a wooden insert. An automated lathe first shapes a piece of ash to the right length and profile. Then an automated drill pierces a hole. To make the sides of the grip, workers begin with 2 pre-cut pieces of steel called blanks. They place them in a manually operated press that shapes them in a 2-step process. They use the heat of a strong electrical current to melt the steel and fuse the pieces together. This is called resistance welding. Next, they feed a steel rivet through the sides and wooden insert and fasten everything together. Elsewhere in the factory, meanwhile, a heated forming machine stamps out the steel blanks that workers will shape into blades. A robotic arm loads the blanks into an oven. In a mere 4 minutes, the oven heats the steel to almost 1,000 degrees Celsius. This intense heat makes the metal malleable. Workers then take out and shape one blank at a time. They have just a few seconds to form the steel before it cools off. The first press forms the blade, in this case a shovel, and a partial socket. Then the second press closes the socket. They quickly submerge the blade in lukewarm water to cool the metal down. By now, the steel is extremely brittle, so the blades go into what's called a tempering furnace for 15 minutes. This alters the metal's internal structure, restoring its strength. The steel D-grip, meanwhile, has been cleaned and painted. Workers insert the wooden handle and nail the parts together. On the other end, they attach the blade, which by now has been varnished to prevent corrosion. After drilling a hole through both the metal and the wood, they fasten the blade using a rivet if it's a high-end tool, a nail if it's a budget model. These hot-off-the-press garden tools are finally ready to put in a hard day's work. A couple of centuries after the Industrial Revolution, mass production met automation, a match made not in heaven, but in high technology. In this special segment, How It's Made honors the automated machine with this moving tribute. It's called gypsum board or drywall, and chances are your walls and ceilings are made of it. Years ago, it replaced plaster as the wall material of choice. Workers just mount the sheets onto wood framing, plaster the joints, then sand and paint. Gypsum is a natural mineral. Since ancient times, it's been mined to produce gypsum plaster. In fact, there's gypsum plaster in Egypt's pyramids. In 1894, a man by the name of Augustine Sackett patented a board made of gypsum which he called plasterboard. But it didn't become the norm in construction until the building boom that followed World War II, when busy contractors abandoned plaster in favor of this faster and cheaper way to build walls. The process of making gypsum board begins at the quarry, where crews mine the gypsum, a soft rock. The loaders dump their haul into what's called an apron. The apron channels the gypsum onto a conveyor, breaking up the big chunks along the way. From there, it's into a giant rotating drum. Within 8 minutes, this hot air rock dryer removes 5 to 10% of the moisture, turning the gypsum white. Next stop, a gas-fired silo called a kettle. It cooks the gypsum at 150 degrees Celsius until most of the remaining moisture evaporates. Feeding that kettle, a mill that grinds the lumpy rock into what's called stucco, a fine powder the consistency of wheat flour. In a mixing tank, meanwhile, workers combine water with several powdered chemicals and minerals, and a chemical soap. The dry additives give the board the required structure, while the soap creates air bubbles to make the board lighter. In a separate machine, they mix the stucco with an accelerator to make the gypsum set faster. Now they combine the two separate batches, creating a mixture called a slurry. It looks like thick white soup. Now they'll form it into gypsum board, which is basically a slurry sandwich. The bread is this thick, heavyweight paper. As the roll unwinds, creaser wheels, as they're called, score a line about 3 centimeters in from both edges. Then a machine evenly spreads the slurry like a sandwich filling between the top and bottom sheets of paper. Then the paper folding operation, most of which is a company secret and off limits to our cameras. They fold the edges along the score lines, the bottom edges upward, the top ones downward, gluing them over the bottom ones to trap the slurry inside. Drops of water smooth out any ridges, ensuring a smooth and even fold. Forming plates then shape the folded edges into straight sides. An optical sensor checks the depth of the board's recess. That's where you put the joint tape to connect one board to the next when you're building a wall. The forming station spews out 305 continuous meters of gypsum board at a time. A cutter now chops that mega board into whatever length board they're producing in this run. As the boards exit the cutter, automated prongs flip them recessed side up. Since the recessed side will be the wall surface, they don't want to risk damage by having it travel face down on the rollers that lead to the drying station. This gas-fired hot air dryer is kind of like a multi-level parking garage. It's more than 150 meters long and has 8 decks. The factory can cure hundreds of boards at a time. It takes 40 minutes to move through the dryer's 4 temperature zones, which start at 350 degrees Celsius and get progressively cooler to 150 degrees. The boards are sold in pairs, so the machinery stacks them in twos, then tapes them together. The tape bears the brand name as well as the size and thickness of the board. Standard lengths range from 8 to 14 feet, and the most common thicknesses are 1/2 inch and 5/8 of an inch. In this industry, imperial measurements are still the norm. The tape also tells the consumer what type of gypsum board it is. There's standard drywall for building walls in homes. There's a moisture-resistant version for humid areas such as bathrooms. There's also fire-resistant gypsum board, usually required by law for commercial buildings. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at www.howitismade.net. The How It's Made crew vehicle is courtesy of Subaru Canada.